So today your class is on friction. As you can see in the screen, there is a mass, it has a weight. So the friction's direction is opposite to the direction of movement. So you can see the right side, the direction of the movement. So friction will be the left side. Friction is the resisting force to move. As you can see in this animation, the person is pushing a block on a rough surface with a force Fa, and the friction force Ff is acting in the opposite direction. If friction doesn't occur, the free body will be as under. Actually, you have done this problem in chapter 2 or 3. You see, there is only reaction force. Once the free body is drawn, only reaction force comes, no friction force takes place. In case of if the friction is occur, the free body is under, you can see the red dotted arrow. This is the direction of the friction force. If we compare both together, we can see the no frictional force and also frictional force. You can see, you can very well compare that in case of no friction, there is no frictional force. But in case of friction, there is frictional force shown by the red arrow. Now what happened? If friction would occur, new force comes called friction, works along the plane of surface, opposite to direction of tendency of move, shown by the red arrow. Now, we'll change this name of the reaction as normal force. As you can see, it is changed. And we incorporate the frictional force. Now friction. Friction is defined as the contact resistance exerted by one body upon another body. When one body moves or tends to move past another body, this force which opposes the movement of or tendency of movement is known as friction or friction resistance. Friction is due to the resistance offered by the minute projections at the contact surface. Hence, friction is the retarding force always opposite to the direction of the motion. Friction has both advantage and disadvantage. What is friction? Friction is a force. Friction force can exist when two substances contact each other. The molecules of each surface interact according to Newton's law of motion. Friction always opposes motion, that is, it is opposite to the direction of velocity. If there is no motion, the friction opposes the sum of all other forces which are parallel to the surface in contact. Friction and surface area. Friction is not affected by the size of the surface area in contact. If the normal force remains constant, but the contact surface area is increased, then the normal force is spread out over more molecules. Thus, force on each molecule is reduced. Friction and normal force. The maximum friction force is proportional to the normal contact force called coefficient of friction. An increase in the normal force results in an increase in the maximum friction. This is because the molecules on the two surfaces are pushed together more, thus increasing the interaction. There are basically four types of friction. As you can see, sliding means once one body will move in relation to others, then the sliding will occur. In case of sliding, two body which are in contact must be in move relative to each other. On the other hand, static friction, there will be no move, but there may be tendency to move. Move will not occur. And rolling friction, if there is a roller or wheels sort of things, in that case, rolling friction occurs. And fluid friction, if actually this fluid friction is used in case of mechanical equipment. Say, in the piston of the vehicle, If there is no fluid, that is, we give engine oil, then friction will occur and the cylinder will be spoiling. So we give friction. We reduce to reduce the friction. We incorporate fluid. Now, the chapter outline characteristics of dry friction or Coulomb friction. This dry friction is called Coulomb friction. Law of friction, coefficient of friction, limiting friction, angle of friction, impending motion, slipping and tipping over. Problem involving dry friction. OS, ladder friction. Problem involving impending motion, slipping and tipping, and rolling resistance. Now, let us know what is the dry friction. Law of dry friction. Direction of friction force always act opposite to which body tends to move, as I have told earlier. The friction force developed is independent of an area of contact. Total friction force depends on roughness of the surface. The more rough is the surface, the more will be the friction. So long body is at rest, frictional force is equal to the summation of all forces applied to the body. Total frictional force is proportional to the normal force. And this proportion or ratio is called coefficient of friction. I will just tell you after some time. Prior to the move of friction force is maximum, and at that time ratio of normal force and frictional force is called coefficient friction. I have told. The coefficient of static friction is more than that of dynamic friction, which I'll show just after some time. Now you check the video. What is the message? Static friction. In this audio, you will learn about static friction. Affect whether or not a hypothetical surface. It can draw you up to a certain height. After drawing up to that height, it slides down. Why? What the surface is if it takes the north one and north state, it has some slide down. If the inclination theta is more than a certain value, this is because of the force of static friction equals mg sine theta. It represents various forces acting on the block. Weight of the body mg and vertically downward. Mg is resolved into two rectangular components, mg sine theta parallel to the plane and mg cos theta perpendicular to the inclined plane. The component mg cos theta balances the normal reaction n, and the mg sine theta balances the frictional force. The force of static friction is I, and F is equal to mg sine theta. When finding the angle of inclination theta, the right-hand side of this equation increases, and so does F. Since F increases with theta, we can say that the force of static friction is a self-adjusting force. However, there is a limiting value of F, beyond which it cannot increase any further. This value is given by F is equal to F m, where S is the coefficient of static friction and M is the normal force. In this example, then theta 0 is the maximum inclination, for which the block is stationary. Then Fm equals mk sin theta 0. Then mg cos theta 0 is equal to mk sin theta 0, which makes this x is equal to tan theta 0. Theta 0 is called Coulomb ratio. Now, static friction. So you have seen the video. In the video, there is some problem with the notation. Small fs is actually the friction force, and mu s is the coefficient of friction. You have seen initially the body was at rest. The more the angle is increased, after some times or after crossing some angle, it started moving. Till such time, it was at rest, it was under static friction. And the maximum is the frictional force which we are concerned about. And after that, the kinetic friction or dynamic friction starts. I can show you in this graph. As you can see, F is the static friction force if equilibrium is maintained. And Fk is termed a kinetic friction force when sliding occurs at the contacting surface. In this graph, we can see in y direction the frictional force and x direction is the force. It is always proportional. Once it reaches the maximum value, then it starts moving and goes under the kinetic friction. And the maximum value is called limiting frictional force, which is reaches a maximum value. And this is the Fs and this is the distance. And the normal force and also the frictional force. The ratio of friction force to normal force is called the coefficient of friction. It is denoted by Fs. Now, explanation of important terms of static friction. Normal force and reaction, friction force, coefficient of friction, limiting friction, angle of friction, angle of repose, important impending motion, sliding, slipping, overturning, etc. Now you come see there is two blocks. One is placed horizontal and one is placed inclined, and this is the gravitation. In case of horizontal block, if movement is towards left, the friction will be towards right, and normal force is perpendicular upward. In case of inclined force, if movement is toward downward, normal force will be similarly perpendicular to the plane, and friction will be opposite with the plane. So you have understood. There is some typical value of coefficient of friction. You can see it. I am not going to discuss. Now, normal force and frictional force. You see, the weight Wmg works downward, that is towards the gravity, and a force is exerted towards right, and movement tendency is towards right. So, normal force will be perpendicular to the plane upward, and frictional force will be opposite to the move. Normal force N is perpendicular to the plane of the contact surface upward, and frictional force Fs is along the plane of the contact surface opposite to tendency of the movement. Now you see another video.
Notice as the incline angle increases, the force of gravity down the incline, what we call the force of gravity parallel, increases. Therefore, the force of static friction, which adjusts in magnitude to keep the book from sliding relative to the incline, also increases. The force of static friction continues to increase until the magnitude of the force of gravity parallel is just barely above the magnitude of the maximum force of static friction, at which point the friction switches from static to kinetic.
That's all. Now I'll explain this thing in the slide. Say in block in horizontal plane, W is equal to mg working downward. One, it is on inclined plane, it will have two components. One is mg cos theta and one is mg sin theta. This is the theta, this is also theta, you know it from geometry. Now, this normal force work upward from the plane at perpendicular to the plane, and friction force is opposite the motion. Say there is no external force here, only the component of mg will work towards right, downward. That's why it has a tendency to move towards downward, and thereby the friction force will be upward. So here you can see Fs and N. Fs is equal to mg sin theta and N is equal to mg cos theta. And board doesn't slide down. Why? Because friction. Now come, if the block is horizontal, no movement, question of friction doesn't arise. Actually, no tendency to move. The block is inclined at the angle theta 1, small angle. No movement. Small tendency of move but does not move for small friction. So the normal force is N1 and friction force is F1 for theta 1, which is less than phi. Now what is phi? I'll explain at the end. Some more angle is increased. Angle is increased. Now the friction force also, actually it will be N2 and F2. However, then more, still it is not moving because the value of theta is less than phi. Still not moving, the value of theta is less than phi. Now the value of theta is equal to phi. It is the last limit of static friction. If we cross this angle, then it will start moving. That phenomena, this phenomenon is called impending to move, or tendency to move, or tends to move. In this case, that is the maximum angle, and the normal force become N and frictional becomes Fs. This is the maximum frictional force. Then what is this phi? This phi is the angle of repose, maximum angle when the block will not move and last limit of static friction, and also impending motion. Just after this angle, a small increase in angle will tends the block to move. More about phi. Say, so far we know these two. Now what else? This is also phi, this is also phi. And as you can see, the resultant force of N and Fs, that is normal force, the angle between resultant force and normal force is also phi. Actually, this phi is the main important. This is the important. We have just proved that if there is no external force, only self weight is there, this phi will be same. So now then this rate phi, what is this phi? That is the rate phi. We can very well find out the Fs. So the ratio of Fs and N is equal to small Fs, which is coefficient of friction. And we can see that mg cancel each other, it becomes tan phi. So Fs is equal to tan phi. So we told the coefficient of friction is small Fs is the ratio of frictional force Fs and normal force N. So this calculate, this come. And from here we can very well write these four formula which will be required for our problem solving. Fs by N is equal to Fs, we have proved. From here we can write Fs is equal to Fs into N, and Fs is equal to tan phi. So phi is equal to tan inverse Fs. This we have to find out this phi number of times. Now kindly start just after this block will start move. If theta is more than phi, we are not concerned about this standard friction. So we have got this formula, as you know, from the previous page. Now, what will happen in general approach once other force is applied? Here you see P is applied. Now this theta, phi, these all are not same. These are the angle theta, these are the angle theta. That is the angle of inclination. This phi, we are concerned about this phi. This phi is the angle between Fs and N. And it is, and this theta is the inclination of the plane, also angle with vertical and direction of normal force.